Welcome to my favorite concept in a lot of math. It's called limits, and it allows us to describe things that aren't true but should be. Take a look at this graph. If you were to kind of like look at it up until this point, and I were to have you guess what the point is at 3, you might guess that it's 2, because like looking at this area, it seems like it's going to get closer and closer to 2. But then when I actually reveal it to you, the point isn't at 2 where it should be. It's way up here at 5. That is bizarre. But there is language in math to talk about it. So, first of all, what the point really is, like f of 3, when I plug 3 in, even though all the other information will be like way down here, when I plug in 3, I actually get out 5. So the true value of this function at 3 is 5. That's simple enough, and that's consistent with everything else you've learned. But like, to say this would imply that the graph goes through this point, and it doesn't. It goes through a whole bunch of other points and then like randomly jumps to this point. In fact, that's what it's called, a jump. So, to describe this jump, we need more information. And what we need is like something that basically says f of 3 should be 2 based on all the information around it. Like everything from the left side and the right side all imply that like once we get here, it should be 2. It just isn't, which is frustrating. So there is no mathematical symbol for should be, and also should be is too vague of a term for us to use in mathematics. So instead, what we talk about is this idea of limits, which is essentially like what all the surrounding information tells us should be true if we were to follow it to its natural conclusion. So the way that we write that is we talk about the limit of an entire function, so the limit of f of x, not a specific value, but the limit of the entire function. And then we narrow it down by saying the limit of that function as x approaches, gets closer and closer to the value 3. So the difference in vocabulary here is that when we're talking about what should be true based on surrounding information, we're going to use limit notation, the limit as of f of x as x approaches 3. And that is complicated, so I would challenge you to like go through the process of reading some limits to yourself just to make sure you're even familiar with the vocab. The limit of f of x as x approaches 3 is 2. And that is different from the actual value of f of 3, because if you look at the graph, the actual value is 5. So the limit of f of x as x approaches 3 is 2. That allows us to describe what should be happening based on the surrounding data. But the actual function value, f of 3, is, based on this graph, 5. This is really cool because it allows us to talk about the same area of the graph, but really specifically. One describes the trends that surround it and what should be true. The other one describes what actually is true, even if it is unexpected.